Okay, good afternoon, everyone. I hope you were able to enjoy a nice lunch and have returned to the afternoon session, nap session. just, just a little joke there for the after lunch session, Dan. And we've got Dan here again. He's going to be talking about proactively reducing system issues by leveraging machine learning and real-time anomaly detection, one of those hot topics. This is session 3BD. When you are providing your feedback, please do provide feedback. It's used by the GSE committee while planning next year's event, and whatever type of event it turns out to be. And I'm sure it's also interesting for Dan to see how he came over. Also, of course, we have the charity. I'll mention that again at the end of the session. But now I will hand over to Dan. Dan.
All right, thank you so much, Anna. So my name is Dan Wigand. I'm an offering manager in part of our AI Ops for Z portfolio. I'm based here in North Carolina in the US. So unfortunately, I couldn't make it over this year to present to everyone in person, but we've done a lot of really exciting things in the space of AI Ops and machine learning when it comes to operations. So as Anna went through the title so nicely and eloquently, I'm not going to go through it, but it's really about how we're leveraging machine learning and looking for anomalies in operational data. And for those of you that joined the session I did yesterday about hybrid cloud visibility, you might see a couple of the same charts in the beginning, but a lot of the content will be very different. The other thing that I ask is I do have the chat up in front of me. So if you guys have questions as I'm going along, please feel free to post them into the chat. I should see them as I'm going through and talking. So I know a lot of times it's good to be able to answer questions in context of the presentation. So again, I wanted to kind of go through on what we're seeing from a lot of our customers. I know a lot of you have seen various digital transformation slides, and it's still true and something that is still happening. You know, was driven largely in part by mobile devices and cell phones and new ways that we're engaging in our systems. So no longer were banks running from 9 to 4 and doing transactions at that time, but I know I go and deposit checks at 10 or 11 o'clock at night or whenever I get around to doing it directly from my mobile device. So a lot of different ways that users are engaging and interacting with systems. And you know, as we all sit here in the global pandemic, you know, that's changed again how we go and interact with a lot of the systems and things that we use on a day-to-day basis. So in terms of what we're doing with IBM Z, a couple of the challenges that our customers are facing is, one, the great thing is that they're really pushing the fact that IBM Z is really the cornerstone of what a lot of what they're doing around IT, and over 80% of our customers are expanding to grow their usage of Z in the next 2 years, or at least maintain the levels that they're at now. And a lot of the key initiatives that they have are really around adopting an approach at resiliency and how we make our systems much more resilient as one of the top priorities. And this is really where the adoption and foray into machine learning is really helping with a lot of this. You know, a lot of our customers have applications that are difficult to support because they're going from across multiple different hybrid cloud layers. We might have parts of our infrastructure running on AWS or Azure or the IBM cloud, but you know, working back down to what we have as part of our private cloud, largely back-ended by IBM Z. So we're really kind of taking an approach to helping our customers accelerate their journey towards AI ops. And we're really going through this in a few different phases. Detect, decide, act, and then ultimately automate. And the drive is really towards intelligent operations. And a lot of what we'll talk about today really falls into that detect and decide phase of the wheel that we have here. So what we want to do is really look at our total infrastructure and be able to detect operational anomalies within that, and really find where those anomalies are happening, and understand what those parts of the systems that are impacted by that anomalous behavior. So if we look at really one of the drivers behind why our customers are driving towards resiliency, and a lot of it is really behind the cost of an outage. For a lot of our Z customers, when our systems go down, they can be very expensive, and the numbers of that tend to be on the left side of the chart, where 34% are roughly more than $1 million per hour in cost, with even a little less than half of that 34% ranging in the $5 million per hour. And you think of, our Z customers are the largest banks, the largest airlines, the largest retailers, the largest insurance companies, all of those largest of whatever across the globe. And it's no wonder why the impacts are that great. And the total cost isn't just necessarily measured in lost revenue, but you also have to start thinking of lost productivity. And in the one case that's over there on the right side of the slide, there was an incident that cost one of the worldwide airlines around $100 million. And this was a few years ago, right before the holidays. And they had issues. So if you think of all of those passengers that couldn't fly that day, they had to get rebooked, so they lost revenue from not only losing capacity on those planes for those days, but also had to cover costs of things like hotels. And there's one other notion that's still there, is the notion of brand damage as well. I know when a lot of the perception is if you had these bad experiences with services, the sentiment a lot of times is, I'll never use them again, right? So you really need to be careful with, how these outages and impacts really affect your end users, because those costs really do add up. And we did have a financial customer that had an outage for a couple of weeks, where their customers couldn't access their financial records, and everything was okay. But they also faced, on top of all of those other issues, government regulation fines that cost them around $70 million. So all of these costs add up, and and why it's so important for us to keep our systems up and running. So what we're really trying to get away from is this firefighting phase and the war room. And the things have evolved over time to where, when issues happen, we don't just pick up the phone and go and call customer service, and a lot of times wait on hold for an hour, 2 hours, 3 hours or more. We no longer email and wait for that response that comes in 48 to 72 hours. We go and take to social media. And I've seen this happen when some businesses have had issues, and folks, will start to light up Twitter and say, I'm having issues. And, the service representatives start really focusing on that social media aspect, because it's immediate for customers, and it's very public as well. So they need to be able to show that good response. And this is really the last place that we want to be notified of issues that have happened in our system. Because what this ultimately leads to then is we get, and I'm going to go through some of our personas and what we've done here before I get down to the technology, is that our IT ops person is getting reports that issues are having problems with the key business application. And if she has no true way of understanding where things are happening, she picks up the phone or sorts one of her war room bridges and calls in everyone that, around the IT support staffs that represent the different parts of the infrastructure, from cloud to support to networking and Linux to Kix, all the way down to the mainframe. And these really tend to be mean time to innocence calls. So everyone has to come and join and say, it's not me, it's, my systems are showing green, everything looks good, until lo and behold, we have the one person that shows, yep, I see something is happening in the database and I can go and fix this. And what we've done here is we've wasted time of the 10, 20, 30, in a lot of cases, individuals that had to jump onto this bridge. These situations are very stressful. They don't happen at 10 a.m. after you've had your coffee and checked your mail. They tend to happen at the worst times. And I know I've been involved in a couple of these, and spent hours overnight trying to get to root cause of issues. So these are really not a fun place to be. And we've evolved our technology over time. And we have a great set of resource monitors. So to go and diagnose that same problem, we have great systems that set thresholds and do alerts and do very deep level monitoring that helps us kind of diagnose when problems occur. And you always want your monitors to go and find things before your customers start reporting issues. So one of the problems that we had in the root of the presentation I did yesterday was, if we start seeing that we're seeing some storage violations in Kix, the problem that we have is that at an enterprise application level, the IT ops person might see a slowdown or degradation in service, but they have no way of knowing really what happened. It's kind of like that ghost in the machine effect, where they see something happening, but it kind of just went away and everything seems to be working okay now. And the presentation I did yesterday was all about how we can start to bring Z data and integrate that in across the enterprise, so that we can bring IBM Z into APM solutions or log analysis solutions like Elasticstack or Splunk, so that enterprise ops has a full picture. So in this case, she can see that something's happening in Kix. She knows who to go and call. She can see exactly where that slowdown is occurring. And in most cases, the Kix SME will say, yeah, I saw this happening in my resource monitors, like my Omegamons. I'm on it. I can go and fix it. I understand what's happening. The difference between this picture and the last one is that at least the enterprise ops person knows what's going on. So the next phase on where we want to get to, and really what the focus of today's discussion is really becoming more proactive and bringing machine learning to help drive the AIOps story. And in this case, our same Kix SME was just alerted that they may run short on storage. It actually hasn't happened yet. It's not guaranteed to happen, but he can go and take a look at his systems before it impacts the line of business. And from that single pane of glass, again, from an enterprise level, she's not getting reports of issues with customers, response times are good, and everything is happy and going well. So what we're really trying to get to is to quickly detect and be able to isolate issues before they really start to impact broader business applications. Now, will this stop things like catastrophic failures or things like that and predict those? Not necessarily, but we are looking at how we're leveraging data to be as predictive as possible. And I'll focus on how we're doing that as we go through the presentation today. So, if we look at a lot of what our SMEs are doing on IBM Z, they're looking at deep dive tooling. They might be using some operations analytics solutions. They have their automation tools, they're monitoring their scheduling. All of those things are still in place. What we're giving these folks is just another great tool in kind of the evolution of operations to be able to look at forecasting potential future problems. And this is really done based on analyzing historical data and trying to relate what's going on in the environment now to what is normal for those systems. So this is really coming from our IBM Z operations analytics solution. So we've really focused on the first 3 lines in the presentation that I did yesterday. We use a common data provider to go and get access to all of that operational data in near real time. We talked about doing hybrid cloud visibility by integrating IBM Z data into various log analysis platforms and providing some insight into what's going on in IBM Z. And the real focus is how we go by and reduce outages by proactively detecting operational anomalies and notifying operations when they occur. So just quickly, we can't do any kind of analytics without having access to data. And this is where our common data provider comes into play. And we'll see as I go through the architecture and some of the flows on how this works, the key role that common data provider plays in getting access to data. It can get access to data in near real time. It can also load data in batch, as we'll see. It has a really large breadth of data that's supported across all the standard IBM SMF types, some third-party types, IMS log, deep collect, RMF3, tons and tons of operational data coming from IBM Z, as it is one of the most well-instrumented platforms that's out there. And we're really starting to apply some advanced analytics to some of this wealth of data that we have. The other key thing that I get asked a lot of times about this is it is eligible to run on zip processors. So all of the runtime components are zip eligible. So we try to take as much advantage of that as possible. Obviously, there's some things like I/O and those kind of things that have to run on the core processors. But in general, most of CDP runs on and takes advantage of zip processors. So let's get into the best part of this discussion is really kind of the journey that we're on towards really getting towards intelligent operations. And so this is going to be a key picture for the next couple of slides and how we're going through the rest of the presentation today. So the first phase is we really have to learn what's normal from history. And this is where we go and use our machine learning engines that we're doing, that we're leveraging to look at historical data and understand what is normal in order to establish a baseline for your environment. And for everyone that's on the Zoom call today, your environments are likely going to be different from anyone else's who's on here. So we really need to focus and scope on looking at your specific environment. And we use the various machine learning technologies to do that. I'll talk a little bit about message-based anomaly detection, and I'll focus mostly the rest of the presentation after that short part on what we're doing with Watson machine learning for ZOS, and that's how we're using that as our back-end machine learning engine. So what we do is we take a couple months of data, and the Watson machine learning engine will go and build a model of your environment. And we have this today for 2 subsystems on Z, DB2 and CICS. We are working on building out support for others. And you know, as I was going through this and working with our development team on this over the last couple of years, it's pretty amazing the amount of data science and in-depth knowledge of IBM Z that really comes into play in order to do something like this. I like to joke that there was a commercial on television here in the US a little while ago around Watson and machine learning, and they put Watson in an elevator in a corporate skyrise in a city. And the next scene on the clip was to show two servicemen show up and say the new guy called us to come and fix the elevator. So they were referring to Watson. And what they kind of glossed over was the fact that machine learning technology isn't something that you just plug in and feed it data and it learns and knows everything. You really have to really understand the subject matter and content there. So in terms of that elevator example, we had to go through and they would have had to have known, you know, operational usage, the different parts and part failure rates that are there within an elevator to be able to go and do some of that preventative maintenance to really understand what's kind of going on and start to understand usage patterns and when things might wear out sooner or faster. So it's not just, let me just send you all of the metrics from an elevator and we can go and figure it out. It takes a lot of knowledge to go into that. And that's exactly what we've done with our data scientists working across IBM with the teams that are developing these subsystems to really get that true in-depth knowledge. So we have a set of KPIs for each one of the subsystems that we support, again, DB2 and CICS. So we take historical data and understand what is normal for those sets of KPIs in terms of IBM-Z. And as I get into a brief demo here a little bit later, we'll see how we've taken those KPIs and grouped them out to things like data sets and storage and CPU. And when we learn what's normal from history, a couple of the questions that I get is, if my environment is not operating as efficiently as it should be, will this tell me how I need to fix it? And the answer is no. So normal is not optimized. It's how your environment operates on a day-to-day basis. So you know, we want to understand, you know, what we would normally or what we would typically see on a day, and really look for deviations away from that. The other thing that I get down to is the topic of data seasonality. And this really refers to how granular we get within our models. And where we've landed within the solution that we've built is weekdays versus weekends. And it's largely driven by the fact that to get very granular with your models, you need a large amount of data. So if we think of trying to build a model that's different for every day of the year, taking into account things like holidays or maybe end of the month when billing happens, or when we have you know, different reporting at the end of the quarter, and try to take all those things into account on a day-by-day basis, we need an awful lot of data to do that. And the challenge is if we need roughly 2 months of data just to do days of the week versus a weekend, think about needing decades of data to really get an accurate model down to that granular level. And none of our customers have run on the same hardware, same systems, and same workloads for that period of time. So we couldn't ever build an accurate model because we don't have the data. So we've tried to land in a spot where we can get a pretty accurate representation of what's normal for your environment. So that's really that first bullet that's there on the chart. So once we have that model, what we start looking at is live data and how that compares to the model. And we're looking for trends of deviations away from that normal baseline in order for us to be able to go out and say, okay, this is anomalous behavior. And anomalies don't always mean that there's a problem. It just means that something is different. So we might have started up a set of jobs that we knew about, or maybe we put our systems into quiesce mode because we're doing a system upgrade. So our workloads are very different. We know about that. We know that that's anomalous behavior. So, you know, we can easily explain those away. But let's say we had an application change for one of our consumer applications that happened on Friday night when we had our typical change windows. And Saturday morning, we started seeing our DB2 active DBATs start to creep up away from where they would normally go under, kind of that weekend workload. And it's not high enough to trigger our resource monitoring thresholds, but it's well above normal and it's continuing to grow and grow. Those are the kinds of trends and patterns that we're looking for. And we would maybe want to go back and see what happened, what changes happened in the system to be able to go and say, we know the root cause of what happened. But in that case, that anomaly, we were able to go and identify and see something was changing before it really impacted the system. We had certainly enough CPU and processing power to handle that, but it was anomalous behavior that was very different when we didn't expect it. So that's really what we're looking for as we're starting to leverage machine learning technology. And once we have that, the next couple of phases is we want to go and be able to deliver guidance. So when we see anomalous behavior for a set of KPIs, this is the recommendation on how we go and where we start to look at next. And ultimately getting down to, if we see anomalous behavior, let's look at this and automate responses to this. So that's really the journey that we're on. And what we can do for all of our customers today is really at least get through those first two dots, and then we're still doing a lot of work on the response and then the automation side of things. So, but as long as we can start identifying that anomalous behavior and giving advance warning, that's really where we need to be to help our customers become more resilient in their operations. So we've had a component within our Z Operations Analytics solution for some time now. It's our Advanced Workload Analysis Reporter. This actually used to be part of the ZOS or the Z firmware up until the Z13, I believe. But this is following that same pattern that we had, but looking at message data. So this is coming from data from Operlog, and it builds a normal baseline of what messages it sees, volume, sequences, and it's looking for outliers within that that set of messages. And it'll send out alerts when it goes and identifies anomalies. Maybe it sees a large spike in messages, or maybe we've seen a message that we have never seen before. So we can go and find those needles in a haystack by understanding what we would typically see and looking for things that kind of deviate from that pattern. So ZAware has actually been used at a major airline here in the US for some time. And in the last rolling 12-month period, actually pre-COVID, there were at least 4 instances where they were alerted of messages where it helped them identify system issues before passengers were stranded, before their flight crews missed their planes or connections. So very valuable for them in terms of keeping their business up and running. So let's take a look at how this works now for metric data. So this is data that's derived from SMF data, and this is where we're using the Watson machine learning engine to go and drive this. And we go back to that little line graph that I had shown. This is really the first dot that's there, is how we go and do the training part of this to build a model that's representative of your environment. So the first phase is we go and take that normal data from your environment and batch load it into our machine learning database. And if we had issues during that period of time, we would want to go and pull those out, because we really want to see how things flow on a normal day-to-day basis. So once we load the data into our machine learning database, the Watson machine learning engine will go and do all the scoring and understand what's normal and build a model that's specific to your environment for each one of the KPIs that represent the subsystems. And roughly 80 or 90 for DB2. There's 60-ish for kicks. And once we have that model, we go into the real-time phase where we're taking, again, data from common data provider that is our live metrics, and we're streaming those into the solution where the Watson machine learning for ZOS engine will go and score those against the model. And what we get out of those is an anomaly score. And this all runs unattended. And we have the capability to, when KPIs go anomalous, to send out an event into your event management system to say, we've seen this, this anomalous behavior. And what that allows you to do is integrate that into your ticketing system, or your contact system, so that we can go and have somebody look at these anomalous behaviors. And just again, anomalies, to reiterate the point, that they're not always a problem. They're just something that is different. So if we know that we've had to run something or are doing changes in workloads, we don't necessarily want to react to those anomalies or need to spend time investigating if we can easily go and explain those away. But if it actually is something different, we really want to know as quickly as possible about those. So instead of trying to strain too much into that little box to see what it looks like, I'm going to go ahead and jump over to my demo system here that I have that shows some data that we've scored for DB2. And we refer to this as our subsystem scorecard. So this is for DB2, this is for our ARS3 subsystem. And we can see here we have the different groups of KPIs across data sets, across CPU. We've actually done quite a bit over the last 6 months or so on really helping customers get more use out of looking at this information and data. So if we just want to look at the high anomalies, we can just filter down and see, we don't have any high anomalies. We do have a couple of lows in there, really drilling down to the most important data. But I kind of want to keep this out to see everything, at least for this part of the solution. So if we go and take a look at our data sets KPI, and we can look at the current number of open data sets for DB2. We'll go and load the data and information from this, and we can see we have what we call our KPI graph. So a few things that I want to point out that's on this graph. So on the bottom, the black line that's going across the screen, those are the actual values of the KPI that was scored in real time. So we also see a set of different bands of information within this. And this is the model that was generated based on the historical data. So we do a lot of statistical analysis that's here, and the light blue bands are what's normal for this environment. And the medium blue bands are in that low anomalous phase. And then lastly, the dark blue bands are anything that would be highly anomalous. And I'll show an example of this a little bit coming up in the presentation. So again, there's a lot of data science that goes into this. And we have a top graph here as well. And that really shows kind of where our anomaly scores are. So we're looking at a data point that has no anomalous behavior. So we're not kind of seeing those spikes that go up into that area. So we can go and hover over and look at all of the real-time data that's here. So I'm going to stop and pause here. So we can see that for our number of open data sets at this point, that's at roughly just before 6 a.m. We had just over 23,000 data sets that are open during this time. Our normal range is between 15,000 and just over 30,000. And we can see where the low and high range anomalies are for the data point. And we can see the generated anomaly score, the last 10 generated anomaly scores for this data point. And I'll show why this is important in just a moment. So if I go and take a look at another KPI, maybe our active DBATs. And this is actually an interesting one to go and look at for our system, because it kind of shows the model really well, in that I can see that my active DBATs really kind of spikes up and goes a little bit crazy between 3 and say 6 a.m. But if I look at what's normal for this system, that seems to happen all of the time as is reflected in the model. So I can go and take a look at, again, my active DBATs. It's kind of going up and down during that period. So let me go and take a look at one other KPI, which was interesting for this environment. And this was our SRB time. So this is one of the CPU KPIs that we have for this environment. And again, to kind of show why we show all of the previous anomaly scores. So we typically, around 5 a.m. again in this environment, see those spikes in data. But we know that Z data is very spiky in times, especially if we're looking at, as we are here, data on 1 minute interval boundaries. You know, everything, all of the KPI values are down around 3 until we hit this one spike where the data goes up to 151, but then all the way back down. And really what we're looking for are trends and patterns in this data, not just the single outliers. So we can see, if we look at the anomaly scores over the past 10 intervals, we had this one data point, which is certainly highly anomalous. So it got an anomaly score of 91, which would certainly be considered a high anomaly. But everything else is kind of in that low anomaly phase. And we don't necessarily want to send out alerts every time we see a quick spike and things go back down to normal. We're really looking for those trends and patterns. And so going back to why we look at the 10 scores there, we use something called the Western Electric rules, where we're looking for so many peaks outside of what that normal bounds is, instead of just looking for that one single outlier. And we can kind of see that reflected in the KPI graph, or the anomaly score graph that's on the top here. Is we can see on the top here that based on the last 9 of 10 intervals, we had an anomaly score of 11. So again, really kind of looking at the whole and not just you know, that single point. We're really looking for those trends and patterns. The other nice thing that we can do within the scorecard is, actually, let me go back and open up our active DBATs again, is we can go and easily take a look at, if we wanted to, the next 12 hours, we can go forward 24 hours and look at what this looks like on the next day. And we can see that on active DBAT, so I don't have data in there. Interesting. But we can go in and take a look at what that looked like through that continuous scoring. The other thing that we can do is, if we want to go and look at, again, active DBATs, we can zoom in and look at a shorter time window. So let's go and take a look at this period of data here, and get down to a much more granular level where we want to go and see. We can even go down to 4 hours total on this screen. So an easy way to go and look at, you know, kind of exactly what's happening on these systems. So I'm going to change the time window a little bit and go back out to the full view. And I want to go out to a day that I know we had some anomalous behavior that was scored in the system, so we can go and see what that looked like. So we can see that we had On our scorecard view, we have a bunch of high anomalous data. Again, we can easily go down and filter down to those pieces. And if we go and take a look at, for example, our SRB time KPI, again, we'll see that we have a large part of forward. A large part of our data that's outside of the boundary here, which is why we're seeing those high anomaly scores. And even in our anomaly score section here, we're seeing where that data lies and how it's out of bounds. They're generating these high anomaly scores. So this is what we're reporting up to the basis that we have there for doing this anomaly detection. And if we talked about, or any of you attended the session that I did on the workload interaction navigator, if we saw a spike in data that's here, we can go out and jump into the workload interaction navigator and understand everything that's going on within the system at that given point. It's doing anomaly detection, but in a very different way than what we've seen here. So something, again, that's very powerful in terms of really understanding what is normal for your environment, and being able to do that anomaly detection and looking for those deviations from normal. So let me go back to this period. So the other thing that we can see is, again, just being able to go out and see how your environment typically operates for a period of time, and just going through the different KPIs, and they're all explained on what they are. So we can go through and look at storage and everything that's truly important to the operational health of DB2. Let me jump back to the deck, and I just kind of wanted to kind of wrap up and summarize everything that's built into Z Operations Analytics. We get access to all of that operational data from Common Data Provider, and we really start doing a lot of analytics on this, and looking at bringing it into enterprise solutions, or what we're doing with machine learning to really get down to that forecasting capability of when we can start to notice those different trends as we're deviating outside of a normal baseline, so that we can alert SMEs or operational staff that something is happening on the system that we kind of forecast to really become a problem within the system. I do have a couple of slides, or a slide here that shows some more information about the solution, the announcement. There's information there about the future subsystems that we're supporting, such as MQ, IMS, ZOS as part of the solution as well. We have a case study from one of our customers, and a set of newsletters that we have to keep up to date on new product announcements and new capability. One of the other things that we're always asking for, and again, this is such a data science driven solution, is sponsor customers. And we've had a great number of customers work with us as sponsor users to help us go and build and fine tune the models, especially if there's subsystems that are of particular interest to you. We're always looking at expanding our sponsor user customer base. And the benefit is that we can kind of work together, and especially if we can have an agreement to share operational data to really help build the solution, so that if we have problems or known issues, we can easily start to make sure that we're able to detect those within the models that the system is generating. So my contact information was on the first slide there if folks want to reach out. It's really beneficial to have as many our customers engaged in building this as possible. So we've gotten a lot of great input from our existing sponsor customers, but in this case, this is always something that I'm open and willing to bring in additional folks that are willing to look at this. It really is interesting technology. And let's see. So next, just a reminder to submit your session feedback. Again, this was session 3BD. The QR codes there as well to go and drive down to that. Anna mentioned the charity that's out there. I'm sure all of you have seen this through the various sessions this week. And with that, I'll go ahead and see if folks have questions. I didn't see any pop up in the chat. I tried to leave 10 or 15 minutes or so in this session because I typically do get a number of questions that I have from folks. So if there are questions, please let me know. And go ahead and either put them in the chat, or Anna, if you want to allow folks to unmute themselves, we can certainly do it over live audio as well.
Yep, I also haven't seen anything in the chat, but I have set people up with the power to unmute themselves and ask you direct questions. So we'll give that a moment or two.
So you mentioned it was a quiet crowd after lunch today, so.
Just let us know in the chat if you're still awake.
Yeah, I tried to answer some of the common questions that I get as I was going through, but there's always some others. So another one that I get a lot of times from customers is, especially now that we're coming up on the holiday season. So I was working with one of the big transportation companies here in the U.S., and they have a large spike in their business sometimes towards the end of November through the beginning of January, as folks are shipping holiday packages around, and their workloads are very different during that time. So how would this go? How would the model represent that change in time period? And really the answer to that is well, we would really want to have two models that we can use for the different time periods. We would have one that would kind of cover February through the early part of November, and then use historical data again to build a model of what's normal for that time period. And that's really kind of where we would look to drive and do that, is use different sets of data from those different time periods to have different models of what's normal for those time periods. So that's another question that I kind of get. So there is a question in the chat about the roadmap. It's not exactly a roadmap link in the announcement. So it's on the more information slide. Let me go back to it here. There was the product announcement. So if you go and into there, there was a statement of direction about us adding additional subsystem support. So that's the text that I referenced. I will say that MQ is one that we are actively working on. So if you would like, please feel free to reach out to me if you want to get more information on what we're doing in that space. So again, things that are included in the statement of directions are things that IBM intends to go and build. So hopefully that answers your question.
Okay, so if there are no more questions, then perhaps this is a good point to finish. And thanks, Dan, for a very interesting session. Kept me awake. And we'll wrap up now. And thanks to all of you for attending.
Yeah, thank you, everyone, and thank you, Anna.
And goodbye to all.